Hello, my name is Osniel Valdivia, and I will now walk you through the project. Just a heads up, if you're using this video for reference, you need to go through the installation and maintenance guide first before attempting to run the project or do any of the things I'm going to do in this video. If you open the code final deliverable, this is what you'll find. The entry port of the application is in server.js. Here we're importing all the packages we're using for the application. Here's the Swagger API route hosted. So here's where we're gonna be establishing connection to the database. That's using this function here, connectdb. So we're gonna connect to MongoDB Atlas, and the URL is gonna be found in this file. I'm not gonna be showing this file since this video is public, but that's the connection string to the database. It also do not commit this file. So here we're using all the middleware of the application. So this is going to be the authentication and role-based authorization that we have. Here we're going to be routing all the URLs. So this is the base route saying, hey, the API is running. If someone just types in /API. So here we have, we're serving the Swagger API. This I'll be showing you in a bit. So this has documentation for all the API routes and all the data models we're using in the API. Here we're routing for users, for auth, for company and employee. And this is the port we're going to be using. We're going to be using 5000. And right here, this is just login that the server started. And then we're going to be exporting this so the rest of the application could build upon what's on this file. If you notice here, it says routes API, so that follows this directory structure, so you routes API. So we have auth, company, employee, and users. So here we're importing the router, or the middleware, the role-based checking, and the express HTTP server. Also validation, we're gonna be, before doing anything in the functions, we're gonna be validating the HTTP request. And then we're going to be importing the company model over here, which I'll show you in a bit. So this is how this function works. You say router.post or .get or whichever HTTP method you want to use. So here is the URL. So this will be here. This will be API/company. So that's where that will lead. So now we're going to be passing in an array of callback functions. So we're going to be using the auth function. That is going to be here. See how there's two. This is the API for auth. This is the middleware for auth. So these are two different components. Here is the auth middleware. So we're going to be checking if the HTTP request has an XAuth token. So it needs to have a signed Java Web Token. So if there's no token, then we're saying, hey, you're not authorized. And then over here, we're going to be verifying the token. Over here, these are check if the user's role in the database corresponds. So we're going to be using these two, auth and owner. So in order to create a company, you have to be authenticated in the system and you have to be an owner. Here we're going to be checking the HTTP request. We're going to say, hey, company name needs to be not empty. So it needs to have some value here. Here this is going to be the callback function. So we're going to say, hey, synchronous request response. This is going to be the main logic of the function. So here we're going to be immediately checking errors against the validation. So you could just copy and paste kind of this code in other functions that you will make and immediately validate the request. Here we're going to be deconstructing the value from the request body. So we're going to be using the name variable throughout the function, and that's what the user sent in through their HTTP request. So we want to be using a try catch when we need to access the database. So this API is going to be stateless. REST API should be stateless. So we're not caching any data whatsoever from the user. So we're just going to be trying a connection to the database, and if it fails, we want to say, hey, a server error, unexpected error with the connection to the database. So here we could do queries in the database, say, hey, find the name here. So MongoDB Atlas is going to return us. We're using Mongoose to communicate with the database. So we say company. We have that defined here in models. Here we have the company and the schema. So if we want to add a field, we would add it here, and this will be added to the database. So MongoDB is schemaless, so we could just add a property here, and we don't have to define or update any table. They'll just be lumped up in the same collection with a different schema. This has pros and cons. As an application grows, there might be some unexpected behavior because of this, but for now this allows us to have a very moldable model and not have many errors as we build the application. So here we find the company by name. So if we say, hey, we already have this company that exists by this name, we're going to be returning a 400 and saying, hey, company already exists. So if that happens, we already have a company that doesn't exist. So now we're going to check if the owner has their company. So we're going to be querying the database saying, hey, is there a company with this owner? And if it does, then it already has a company. We don't want to give them another company. This logic could be removed depending on the context. If you want to allow two owner, one owner to have many companies, you could just remove this, and that will work like that. But for now, this is the context that we have. And if all these conditions fall through, so we have a valid case here, we're going to be building the company model, and we're going to be saving this in the database using this logic. So I want to emphasize this coding pattern here because it's pretty important to code in this way. A lot of people code a best case scenario to worst, so then their functions end up looking kind of like this, more diagonal. These functions could get very big because a lot of needs to get in consideration with these routes. So we would want to check worst case to best case. So we say, hey, if the company already exists, I don't want to do anything else. We're just going to return that the company exists, and then not have the rest of the logic dangling as we would have in an else. We would have to catch all those conditions at the end. Here, the next condition, and if all these are correct, then we have a valid response, and we don't have to have a lot of nesting. Right here is just the get. The gets are a little bit more simple. We're just going to be querying the database directly for this information, returning it. The middleware does most of the work. We have authentication and owner guard that only owner could get the company like this in this route. Here you could pass in an ID here as a route. So this would be the / and then the ID of the company. So like, let's say a user clicks on a company, returns the ID, sends a request with this ID on the URL, and this again has a middleware and then synchronous request response. And here we don't do any validation. We just say, hey, we can find it by ID, and if not, we say, hey, company not found. So that was the API component of the application. Another component of the application we worked on was the test. So here, this is our test file for the company routes. So we're going to be using Mocha Chai and Supertest. All the packages could be found here in package.json. So here are all our dependencies, and as soon as you do npm install, this will install all these dependencies. So you can have all those packages that we used. First, we're going to be saying, hey, the environment, we're going to be in a testing environment, import all the packages that I mentioned that we need to import, import the server, and we're going to be saving variables so we can be testing. So this is the owner we're going to be creating during the test. We're going to be saving his name. We're going to be using Faker to just generate a fake name. This is kind of unimportant, but you could get some data that looks generally accurate as opposed to just have random letters and numbers. So you can have more sophisticated testing. Here we describe the test suite, so we could just nest these inside each other and keep describing tests. So we just say, hey, describe, and then we pass a callback function. In Node, a lot of it is callback functions. So we're going to be generating a company. We're going to say, hey, we're going to set up the database. And this is the test case itself, the it statement. So again, this is saying, hey, it, and then should empty database. This is the convention on how to use this library. Then you pass another callback function, and then you return, hey, this drop database, then expect. This is the validation part. So this, we expect this to be true. So this is how you would use it. You could just use, you just say, hey, expect, and then an object. So let's say, hey, result in this case, and then, you know, to be null. And then this will say, hey, this needs to be null. If not, we're going to be failing this test. So we're going to be expecting the result to be true here, that we dropped the database. Here we're going to be setting up the users. We're going to send a request to the app. We're going to be using this route. So using super test, we could send and test the HTTP routes. So we're going to send the request body that we built here. Again, we got to save all these in variables. You know, these tests could get kind of complicated. So then we send the request, we send the body. We expect the content type in return to be this. We expect this HTTP status response. Then we're gonna be resolving the result, and then we expect the body token to not be null. So we got our Java Web Token signed, and we're authenticated in the system. And we're going to be setting our variable here to be that token. So now we are logged in for the rest of the tests. Here we are going to be changing the user type to owner. That's this test. Here's a post. So we're going to be doing the same code format that we saw above. Again with this, and many of these tests, we're going to be testing, you know, the API. So we're going to be using super tests a lot. We're going to be sending requests to the application. And with this, we could hook this up to the next part of the application I'm going to show you, which is Docker. So this is our Docker file. We're going to be building off Node Slim. So this is a Slim version of, I believe, Ubuntu, and is pretty good for this application. We're going to be exposing the port that I mentioned earlier, the 5000 port, copying this, and then installing everything. And here's the interesting part I want to show you. We could build this, as soon as we build this Docker image, we're going to be running all these tests, and if any of these tests fail, then we're going to be failing the build, and thus not deploying a faulty version of this application. So if you keep your test up with the code you write, you could ensure that no bugs will just enter production, which is highly valuable in an application. And then this is just our prod image. If everything goes well, then we don't have much here. We just have the API, and then Azure can scale this up if necessary, because the Docker image is very scalable. I also want to show the Readme file. Readme files are very important to document your application at a glance and get users to really understand what's going on. You could just write it kind of using the markdown syntax, and if you click preview, here's how it would look like. So these are all the instructions I'm going to be going over in the next video, but for now, let's go run the application. We have the scripts here in package.json. So now let's run the application. We could use npm scripts that we have in this application to run the server. So we could type in npm run server on any CLI in the directory, and this will run the application. This will use nodemon, which detects any file change and automatically refreshes. So let's go run npm run test, and to show you all the tests running. And so this makes sure the API is working as expected. Here's the image in Docker Hub. So this is where it's hosted. All the credentials will be provided in the final deliverable. and here's the Swagger UI hosted on our live website with all the details on how to interact with the API. That's it for this video. Thank you so much for watching.